This is question number 1 from the 2000 AP Calculus AB exam. Okay, so for part A, we need to find the area of this region R. They're restricting us to the first quadrant so that we know our limits would be 0 and then up to something close to 1, but they don't tell us explicitly that these two graphs intersect at x equals 1. So we're going to have to solve an equation here. So I'm going to write up above. We want to know where these two functions intersect. Now you can use your calculator, graph them both, find the point of intersection, and that's going to happen at 0.941-ish. Now write down as many decimals as you can get, and we're going to use them all in our calculations. But just to make things a little easy, I'm going to say that we're going to call this A, so that we don't have to write that whole decimal in each part. So for part A, we've got this integral. We're going from 0 to A, and for the area, we use this distance here. So that would be e to the negative x squared minus 1 minus cos x. And we put all of that in our calculator. This is the only thing that we have to write. And you're going to get 5.590 or 0.591. Either one of those answers would be correct. Okay, part B, volume. Okay, we're going about the x-axis. So I'm going to draw my rectangle right in here. So it looks like we're using washers. So we've got pi. We're going from 0 to A. And our outer radius is this distance. So that would just be e to the negative x squared. And then our inner radius is this distance here, which would just be 1 minus cos x. And then we square that. And now there are a variety of answers we can get from this. We could leave this in terms of pi, or we can write it as 0.556 pi, or we can multiply by pi and get this, or 1.747. Any one of those four answers would be correct. Okay, then on to part C. We're looking at cross sections. Again, we're going from 0 to A, and our cross sections are squares. Area of a square is side squared, and one side of the square would be this distance here, which is just the difference between the two functions like we did in part A. So it's e to the negative x squared minus 1 minus cos x. But we have to square this whole thing. And that turns out to be 0.461. Now take note at how similar the integrands are and how a slight change completely changes the whole problem. For part A, we've got the difference between the functions. That gives us the area. For part B, we've got this coefficient, but then we've got the outer radius squared minus the inner radius squared. And then for part C, we've got the difference squared because that would be the side of a square, and the area is side squared.